All right, we might as well begin. Hello and welcome back to those returning viewers on Twitch. Welcome back to the channel on YouTube. We really appreciate you checking us out and sticking with us this long. It's been a blast. It's been a lot of fun. If you like what we've been doing, definitely like and subscribe. Hit that bell notification to be informed of new videos when they drop. Let's get a little crazy and maybe impossible, but you know what? Let's try pushing for 1 million subscribers on YouTube by the end of 2026. What the hey? You know what? Nothing ventured, nothing gained. So let's be crazy. So the last stream we did the through hole assembly, started some of the test process, and started recording some of the results. But before we kind of continue, something cool has come in. So the power resistor, let's switch over to the webcam. So the nice big 200 watt chunk and power resistor is here. Pretty cool design. 0 to 50 ohms, more than enough to build the loading test fixture. Nice heavy duty wiper. It's kind of interesting about it. It looks like it's got a brush from a motor. That's how it connects the wiper to the system. So hey, you know what? Whatever works, works. All we need is to do resistance. Kind of check this bad boy out. Because again, I'm not an unboxing channel, so I went ahead and unboxed it. So let's see, maximum resistance, so 50.8 ohms. And as typical potentiometers go, we'll go down to practically a dead short. We'll have to keep that all in mind to test. So we'll probably have to ensure that we set our resistance value first before actually hooking it up and engaging something. Or starting with a really high resistance value and then slowly dropping to the desired current pull. Because I also picked up that should be coming in with the next day or so, panel mount ammeter. That should work with this system for what we need to when we're measuring, raw full current, like, at least in the hundreds of milliamps. Full amps to, hundreds, like 2.5 amps or whatever. This should be more than sufficient with a low-cost panel ammeter. And I'll get I have a box, an enclosure box I'll use. I'll get everything mounted in, make a nice little test fixture, and get it set up so we can take readings and stuff. But this will be a good start to our test fixturing. And it'd be something that we can use, that I can use later on, and we can use later on in other projects. Yeah, so that'll be a good, fun little thing to work on. So I'll switch back from that to the main screen. Since we do need we will need the multimeter. And I did print out a copy of the test plan to make it a lot easier on myself, so I don't have to sit there and try to remember everything and try to crane my neck looking at the screen while also trying to do this on video. Another thing I did accomplish too, I want to kind of share, which will make things easier, is I switch over to this. So I managed to get my microscope connected. I got to kind of adjust the lighting a little bit, do something a little bit better, but it'll at least help me get better views on things, especially solder joints. It's not like autofocus or anything, but it's better than trying to show details with my phone. We can get in there. I can show you more what I'm talking about, especially with small items, especially solder joints. So we should be okay there. If not, like I said, we'll go through and fix this one. If we've got any shorts or bridges, which we might, but I'm not sure. We'll know when we go to power it up and program it if it doesn't want to program right. That's, we'll go through and fix it. try to pull off the extra solder, but right now it looks like it might be fine. May have to just manually replace the switch, but again, we'll see. So yeah, the microscope will definitely help us, definitely help illustrate what I'm trying to show and explain about solder joints and stuff. So if you're working on boards and you've got through-hole legs that are quite long and you feel the need that you have to trim them with a pair of side cutters or nippy cutters or whatever, one thing to keep in mind, you do not want to cut them too short. You definitely don't want to cut against the board because you don't want to mechanically stress the solder joint, because you'll undo everything that, the whole purpose of what you're trying to do. The whole purpose is not only a mechanical bond, but also the electrical bond. You put too much stress there and you have a chance of breaking the solder joint. So just keep that in mind for future reference if you ever have to trim down legs or leads from like LEDs or things like capacitors and stuff with long legs, like through-hole capacitors. So that all taken care of, I'll let that kind of sit there and cook and switch back over to the phone. Again, I'm not going to terribly worry about filling out the sheet right now. We still have to create a serial number label. Since today was a work day, I didn't really get a chance to do much of that, but we can go through at least. I also brought my kit for JST terminals. So if we get a chance to get to putting the fan together, just to kind of illustrate this little guy, I got this off of Amazon as well. While they're not official JST crimpers, these things work really nice. And this particular kit has the crimpers, a set of wire strippers, come on out, and a nice selection of JST connectors, pins, and sockets. So it's really handy. It also has some of the DuPont connectors, which are the type that goes on the headers here. So it has a selection of them. So if you ever, looking for something like this, like I said, I got off of Amazon JST kit. So this is really nice. And the great thing is these are JST parts. They're not some aftermarket. These really aren't made. There's no like solder pins or anything. They're all terminal, crimp-on terminals. So if you want to make like extension cables, you'd have to do some soldering to your boards or whatever. But this is great because it also has, funny enough, it should have the parts right here, the same parts to go into the terminal, the connector on the board for the fan. So that's the wrong one. That one's too big. I know it's in here. I know it's in here. They all got mixed together somehow. This is it. Yes, that's it. Yeah. So if we run out of parts with the Mauser bot stuff, we have enough parts to build. Yeah, they kind of blended some of them together, but that's not a big deal. So when we get to that is when we'll worry about this. A little bit of a pain to use, but it works pretty good once you get the hang of using it, mainly getting the stripped wire end into the terminal once it's all set. So again, I have the printed out document here. I'm going to grab myself a pen on my little holder. Mainly to help keep me track of where I am. Basically, that way I can kind of go through all of these guys. Now, we did do a bunch of tests with the resistance last time with the meter. We went through and we checked the power supply. We checked all that. Let's see here. We checked all the limits in the input, so we did that. Just make sure that we aren't inputs. Okay, yeah, so another thing I did grab some jumpers. So like idealistic, like I was saying, so I think they're going to be black jumpers from Mauser, but again, these are just generics. So schematically, with that jumper enabled, BNA should have 120 ohms resistance. Not an overload, which is wrong. That should not be, because schematically, let's pull up my printout. Schematically, yeah. Unless I'm, oh, you know what? Don't tell me I got those. No, one. Oh, pin one. 1 and 2. Now there could be a layout issue. So yeah, between A and B there should be 120 ohms. Because here's 1, here's 2. Wait a minute. I'm not getting it through the terminals up here. That's not good. Let's make sure I'm getting them down here. Did that actually register? Okay, yeah, I'm just not getting them on the terminal screws. They must not be making connection. Okay, so that's good. That was one of the tests that I was afraid that it failed, but it's fine. Because it just wasn't picking up on the screws. They must not be making enough contact, and that should be practically open. At 360K, that definitely passes. So we'll have to remember that. We can also come in through, since the backside of these connectors is kind of open, we can come in through the backside. Yeah, 360K. Put the jumper back on and double check. 120 ohms. All right. All right, perfect. So that validates that. That's fine there. CN4. Okay, so these are the inputs. So we're checking. Make sure there's greater than, I think 1K is what we're looking for. Yeah, we're in the meg ohms, so doing the common. Yeah. And again, we check the DC voltage. We're definitely not shorted out there. Now we're going to check the motor. Oh yeah, meg ohms. Meg ohms. Trying to keep everything visible as much as possible, and I apologize. Meg ohms. Meg ohms. Now, what we can do is, no, that's ground, so, oh yeah. No direct shorts between ground and any of these terminals. Perfect, perfect, perfect. So those terminals. So we got all the terminals checked out. Okay. Here's another one, TP24, which is V-Bus. That's for the USB. And TP25, which is ground. Definitely don't want a direct short here. Okay, there's capacitors on there. It's charging up and it's slowing down. Okay, we're definitely well over the resistance rating. All right, so that's fine. Now, TP22 and 23. Definitely no problem between it and ground. Definitely no problem between it and V-bus. Definitely no problem. Again, you don't want to accidentally fry anything by having things. 18 and 19. So these are your RS-45 signals. Oh yeah, megohms. 20 and 21. Definitely. CN7. Okay, I checked all that. That's all the grounds. That's all. That's the motor, the stepper motors. Okay. Yeah, we're gonna fix all this to make it less wordy. Get all that. All right. So here's the cool thing: is that the resistance measurements are all positive. Everything looked good. So just kind of switch over to here. Oh, okay. See. Yes, that's fine. Oh, save that. We're going to go and change this date. Save it. I like to save it. Like I said, we got to get the PCB serial number. So something we should do here. That I don't want to be. What in the world are you doing? 20 point. What in the world? I don't understand why this thing does it. Why it did that? That is so crazy. Pull the leads out of my meter real quick, just make sure it's easy. You know, that was a little easier for me to check for serial number. There we go. So, again, now this was actually calibrated from when I worked at my one of the last companies, but that was in 2020. So that was about 6 years ago from today. Actually, almost exactly. Well, no, almost 6 years. About the end of the month. And they're only good for a year. But it was calibrated at one point. And it passed calibration, had a certification on it. So I'm going to switch over and kind of show you what you'll see. So technically, has it been certified? Oh, so typically you'll see, yeah, as best as I can. So they put their own calibration label on here. Basically it has an asset ID, which was basically the ID number. Customer ID, which is our customer number. The data was calibrated, and when it expires, basically when it's due by, then they have the little QR. So to let you know, I can always throw this in the resources, but the company is local here to me in Ohio. To us here in Ohio, it's Total Calibration Solutions. Just in case you're out in this area, this is where you are, Ohio, Northeast Ohio. Really good company. You can mail stuff into them. Just to keep in mind, calibration is not cheap. It is expensive because there's a lot of expensive equipment that is involved in calibration. So, and even the calibration equipment has to be calibrated. And so it has to be sent out to a special lab to be calibrated, typically an actual NIST lab. So, technically, since we're not ISO, but I like to have everything as if. because this saves headaches in the long run if you actually when I actually do want to go to that route. And again, it still creates the chain of accountability, and you have answers to any questions that might come up to you. That's why this is all important to me. I'll have processes and policies and everything in place as if I was going to be ISO certified. And I will do my best to follow those policies and practices. Okay, my meter went to power off mode. All right. So, here we go. We have the voltage tests. Basically, since I've got the test plan printed here, I will we'll go through what we're doing. I have to switch back to that, but no, I won't switch back to that right away. So, kind of move this out of the way. I don't want to break anything. So, just to show you, this is, again, I'm not getting kickbacks or anything. I'm just showing you what I'm using so you have reference, so you understand what I'm using, what I'm doing. This is my benchtop power supply. You go up to 60 volts, 10 amps on DC. So far, it's been really reliable to me. So I'm pretty happy. It's got a serial number back here. Again, it hasn't been calibrated yet, but it can be. This brand has been pretty reliable. So I will say that I am pretty happy with it. So in the spreadsheet, I'm just going to add this as a piece of test equipment. Real quick, I like to get this done. X102. That way we have a complete record of everything we've done. All right, I'll put that back over here. All right, got that equipment set up. Okay, so let me get this guy plugged in, get it connected to mains. Turn them on. So one of the things I like about this guy is current limiting. We can even limit the output voltage. So we want to set to 5 volts. So we want to set the overvolt protection. So it looks like 8.4 volts is the maximum protection we can do. Over current protection, 100 milliamps should be, 400 milliamps is the minimum we can do. So we're going to set the actual voltage. Well, that's our limit, so it should be fine. Current. Let's see if I can, oh, okay. So I can put it to push only 100 milliamps. So that's fine. On, off, okay. So, kind of set that aside. Now, grab my handy dandy wires here. And we're going to plug that to positive. Grab a handy dandy screwdriver. Flathead. So our positive voltage is up here. You know, I want to trim that down. I don't like how long it is. I don't want too much of it sticking out of the back. Idealistically, I'd have ferrules on this, but Just grabbed these because they were what I had to work with for this video. I'll get them cleaned up and either ferrules or I would tin the wires. Ferrules are better. Ferrules. Now, if you're new to this, to electronics, show you ferrule. Or these little guys are, you strip the wire, you for an extended length, you push them into the center, and then use a crimp tool to crimp it all down. Ferrules, however you want to pronounce it. They're really nice. They help keep make sure the output is off. I like this because the output LED actually turns blue when it's on, and the screen actually lets you know. All right, so that's off. I don't want it to short to itself because that gives us a false negative. All right, so here is probably the beginning of some of the most potentially dangerous things. Now, what I did there, honestly, I'm going to say is dumb. Tightening those down while they're in the connector, it just puts undue torque on it, and you could damage your solder joints or damage the connector. You don't want to do that. Don't copy me. Have it out of the terminal block, and tighten it with it in your hand or another jig or a bench vise or something. Don't do that. You don't want to risk too much mechanical stress. So we have our bench supply set to 5 volts. Current maximum output is 100 milliamps. Limits at 400 milliamps. So that's the limit of this power supply. Output is disabled. Connected in that. Now we're going to kind of pull ourselves back, and we're going to see if anything decides to smoke or the power supply get mad at us. All right. Okay. All right. This is very positive. So far, so good. No smoke. Nothing went boom. Nothing exploded. This is a very good positive sign. Okay. So you can see the 5 volt and the 3 volt LEDs, the power good LEDs, are on, in fact. So it's our first visual indication that we've got positive light. And the current limit isn't tripped. Right now, the power supply is telling me that it's only pulling 27 milliamps. If you can see that, but yeah, 27 milliamps. Maybe I'll get more cameras set up. I don't know. I'll try to do better. Try to do more in the long run, but it's kind of tough. Especially because I'd rather spend money and time on test fixtures and actually building the projects. But I do need to equip myself better if I want to do more of these videos. So right there, boom, that's that would be a pass. So our first power on test, our smoke test, passed. So now put the output off, and we're going to set the voltage to 24 volts. All right, so I gotta set my limit. So what's nice about this power supply is it has an RS. Okay, it does not like that, so I'm going to go to over voltage and kind of pump us up a little bit. It has an RS-232 serial interface, and if I really felt like it, I could set up something that can automatically, automate it if I really wanted to. But right now I'm not worried about it. So we're at 24 volts. And the current limit to 500 milliamps. Over current protection. 500, we'll set the over current. And we're going to set the current output. All right, so we're 500 milliamps. And so this could essentially push more power down to the board, and we could have problems here. Okay, we're actually, because of the rules of electronics, current draw and everything, we're actually pulling less current than we were at the 5-volt, because now the power supplies aren't struggling to, especially the 5-volt supply isn't struggling to hit the 5-volt output. So that's really good. And we got nice bright LEDs. They're both very similar in intensity at the full 24 volts output. That's because we matched the resistors to give about, I think, 10 milliamps of current, about half of their full brightness. So they're nice and matched. That's one of the things I'd like to try to do with designs, and match brightness among LEDs. It can be a pain in the rear, but it can be done. So wow, that is pretty cool. We are good there. So we're going to take our meter, put it to DC. Auto's fine. This will work just fine. We're going to check our power rails. Ground's here in the middle. 3.3, almost right on the nose. You just got to count your tolerance and slop. So the buck regulator's going to have a tolerance. The inductor's going to have a tolerance. All these capacitors are going to have a tolerance. So to be practically 3.3 on the nose is pretty damn good. Now we're going to come to the 5-volt side. 4.979. That's pretty damn good. Again, you're dealing with the same tolerance values between parts. So our 3.3 and our 5-volt sides are showing proper voltage. That is happy days. We are good there. Okay, that's 3.3. Yeah, because we have 125 millivolts. And that 3.3 is definitely within the 125 millivolts. That's definitely within, the 5-volt's definitely within 125 millivolts. All right. Put any more USB-C. Oh. All right. Hopefully I've got a USB-C cable long enough to connect. I hope I do. If not, I will have to borrow an extension cable. Yeah, let me borrow one of my extension cables. Just gonna get it from my webcam from my other workstation. We'll borrow it for now, since we're not going to need it for this. So I'm going to switch back over to the desktop real quick so we can watch this. Main screen. Well, let's go ahead and all right. We might have to finish some of this testing tomorrow, or I might just run out away real quick to my office, which is right next door, and grab my FTDI cable, because I kind of forgot to grab it. That was my fault. But we can at least test this and see if we can actually flash and do the Hello World program. So we're going to bring up the device manager so we can watch to see if the serial port shows up. So right there. So I'm going to connect the USB-C cable to the USB-C port. Okay. Well, I will say the Windows pop-up messages are a success. Kinda. So let's close this. Let's bring it back up and let's see. Because sometimes device manager is weird. You got to force it to refresh. Come on. So what I do is I'm going to remove that because it's not installing the actual. Again, for hardware changes. Okay. Well, it's not showing the actual. Maybe because this is an older Windows 10 computer. Maybe I have to actually download the proper drivers, but we'll see. This might be a me problem down the road. All right. So we're going to go into projects, stepper controller, firmware, basic modules. We're going to do the open with code. Hopefully this computer does not get mad. It's probably got to download. Nope. Nope. Leave me alone. Okay, bye. All right. So we're going to see if COM19. Huh. That's new. Let it detect the device automatically. So for one, let's see. This is new. I've never tried it, so let's try this. Yeah, I don't think it likes the serial port, but it may still work. COM19. So what we're going to do is we're going to build it. Now that boot button might be causing a problem. Why? Why? Wait a minute. Okay, did it? No, I think it built. I should have done this earlier on my own time. Just build it with the dev kit. But I might have to also install the Silicon Labs, the Scilabs driver for that chip on the computer. I should know. I shouldn't have to because that's the same chip that's used on the ESP32 dev kit. So I'm just hoping that's not a like where the computer has to be rebooted or anything. If I run into problems, I will we'll kind of divert, see what else we can test, which probably isn't much without being able to flash it. But we can at least throw the fan assembly together and, yeah, because I use this workstation here to do work, to do some development work with regular ESP32s. Hopefully this didn't update to version 6. Excuse me. Because if it updated to version 6, that could be part of my problem too. Especially when we go to do some of the other tests, like the UART, FTDI interface and stuff, because the API library's changed. Okay, I'm gonna get this bright light source out of my way. Okay. This computer's a little slower. It's an old Core i7. It's only a quad core. It's my old rig. Recently upgraded to something a heck of a lot better. My new machine slams through compiling code like nothing else. And then if you want to do something like FPGA programming, you don't want to use an older computer. Just because the amount of compiling the system's got to do for an FPGA. Oh my God, this computer that I'm on right now. So just a basic program that uses SPI to read a sensor. It takes like 30, 40 minutes for this thing to compile from scratch. All the things to do the FPGA fabric and everything, just even program just to see if you worked right. Yeah, it takes like 40 minutes for this thing to compile all that stuff for the FPGA chip. My new machine in my office slams through it so fast that I don't even have time to get up and grab a drink of water. Okay, so it did program. Let's see if it flashes. I'm hoping that boot button's not a problem. Now, sometimes with first flashes, sometimes you got to force it. Because sometimes the auto programming doesn't work. But it might not like port 19. Or it might not like that switch. it might be slightly shorted, which is triggering it. Might be too much. Let's see if I can get a terminal on this. Okay, so it can't actually access the terminal. Sometimes we've got to, and I've seen this with new USB ports. Sometimes yeah, I think we're gonna have to throw in one to find the right drivers for the Scilabs chip. I was really hoping not to. Let's try this. Driver. Update drivers. No, I don't want to do this. Install. No. You want to be a little... No. Nope, I was afraid of this. Come on. Yep, so what I'm probably have to do... Yeah, it's kind of crazy because it's not showing the actual CPC 2102. Yeah, so what I'll do is I'll work on fixing that off camera. It's a damn shame, but let's see, maybe it'll flash. We'll try one more time. Sometimes I have to close VS Code and bring it back up. Code. Try one more time. Sometimes code is very finicky with me. Come on. Will you start up? Yeah. That's perfectly fine. Probably a driver issue. Probably because I'm on Windows 10 on this machine. Disappointing shame, but that's fine. Them's the breaks. Sometimes that's the stuff you've got to deal with. Yeah, so... I mean, it takes too terribly long to download the driver, but there's other things we can do on camera. I can do that off camera. But the positive thing is, so... System recognizes it. So it does. We can't do these two. We can't. It does recognize that there is a serial port there. So that is a good positive first step. It's just, I personally believe it's a driver issue. So I'm going to need that. So we will set this aside to continue in our next stream while I do some serious troubleshooting. But again, positive note, the board is working. Yeah, that's what I get for not fully preparing off camera, but you know, fortunately the way it goes. All right, so, but the good thing is I left the board's been powered up the whole time. The good old random touchy test. Not a scientific method, but I do it all the time with new boards. Nothing's hot. The board's actually nice and cool, especially around the regulators. I don't expect them to warm up right now without drawing any load. We'll do that later. But positive first signs. Positive first sign of life. So I disabled the power supply. take it off so I don't accidentally turn it on. Turn my meter off. But that also tests to make sure, you know, it lets us know that our shot key's in the proper orientation. Again, I got to fix that footprint, and we'll get that footprint fixed. So let us, excuse the printout. My printer seems to be needing new toner, and I will probably get some later. No rush. Nice USB UART. Go. This is mainly for my reference to help us wire up the fan. So we have our connector, our funky little pins, the terminals, and our cool little fan assembly. Kind of pre-stripped already. We'll have to trim them down just a hair. Now, I'm not going to adjust the... actually, what I need to do first is pull up the data sheet and get the color code for this fan. So, let's do that real quick. Because I know, you know, red is the positive, the 5 volts, black is ground, but I can't remember which is TAC and which PWM. I'll just jot it down on here, but let's see here. CFM-4. Go, got the fan, data sheet. Right here real quick. So here's the data sheet. There we go. Yeah, so I'll just kind of jot these notes on this. Red. Minus yellow and blue. Blue is PWM and TAC. So yellow is TAC. Okay. All right. Back to this guy. Yes. Let's not pay too much attention to my handwriting, please. It is horrible. I know it. But that's what you get when you spend most of your time working on computers. I'm losing my mind because I do not know. I do not remember where I set my goofy tools. I think that the ghost of my workshop is there. They are striking and haunting me because things are coming up missing. Just need this little guy. All right. Won't need any terminals out there, so we're gonna need one of these little guys. These little fellas. All right, so zip strip, whatever you want to call it. I call it finger cutters. This is really good to hurt yourself. This is loaded up on the strip for a machine that actually can handle this. There are automated machines that will do this. So large batch scale batch production, I would let's say you're pumping out thousands of these things. I would definitely contact a harness house or a company that has this equipment and have them put together the fan assemblies for you, because they have the automated equipment that can do all this, and they're better suited for it. But that's like if you're pumping out thousands of these things a year. Small volumes, you just got to get used to doing it yourself because the cost will just be too good. Handy dandy crimper tools. Again, these are a pain in the ass to use. But first, especially for the smaller your terminal, the more of a pain in the rear they get. So we need to see how much trimming needs to be done on that. I mean, realistically, it would work at that, but that's a little too long. Let's see here, they're all roughly the same length. I I don't like that they're not all the same length, because then you kind of get weird. But I'm not going to worry about that right now, because right now we don't know if we want to trim these down to, to actually accommodate the case, the assembly that we want to design for it. That way you don't have too much excess wire that can get tangled in here. For now, this is for testing. We definitely want them as long as we can from the factory. So the way, you know what? We are going to switch over to the microscope, because that would only be easier to show you what I'm trying to show you. That. You got the microscope, switch back over to it. Got a pair of tweezers. All right. Oh my God, so much better, so much easier to show you guys. So with these kind of connectors, so this part up here is what actually holds to the wire. That's what grabs hold of the wire from the crimpers. This smaller part back here is for insulation. So you need to trim, you need to have just enough wire to go through to get caught in this section where it actually grabs hold of the wires. Like I said, this is for insulation. You don't have bare wire back here because that won't grab the insulation properly. It won't grab hold of it. So that's the proper way to use these connectors. So let me grab these wires. Let me grab the red because it might show up a little bit better on the camera. I'm going to grab my tweezers. So basically you're shooting for this. You're shooting for this when you assemble it. That way the part in the back actually wraps around and crimps to the insulation, and that's what will give you your holding power, where it'll actually stay on the wire much better. And then again, like that center is what grabs hold of the wire itself, the actual conductor. Now that's excessively long, and I already launched one of those down on the floor. I'll have to grab another one out of the bag. That's why you order extra. You learn as you do this that you'll find what parts you have the worst habits at launching across the room. And with me, it's usually the smallest parts possible. And when they're gone, they're gone. You're never finding that. I'm never finding that little guy again. Unfortunately, it's gone. It's gone for good. So, to go back to the... All right, so hopefully... Okay, actually, so these are basically dies. It's called a die pair. So let's bring one of them in. So 32 to 28 AWG. That's more likely what we'll be using. So I don't know if you can see, but it's kind of stepped. So essentially, you'll be feeding the wire in from this side. You'll be kind of cradling the connector into here. That's tricky to get set up. And then basically what happens is with that step, you'll try to push the wire through and use the step to hold the insulation, and that'll set your depth gauge basically. That way you're not pushing your insulation too far in, because if you go into that center part, you're going to wrap around insulation and not even grab hold of the conductor, and it's not going to work. So this is where a lot of the fun begins, but as I said, the wires are a little bit too long. So we're going to just shorten them there. We don't need to go too short, but just enough. Because you don't want them to go all the way through and interfere with the pins in the actual connector. You don't want it to interfere. And then sometimes if they're too long, it gets unwieldy. So the way you would load this up, it gets to be a pain in the rear. So you're trying to, let me see if I can do the microscope again. So I want to kind of, teach what I can here. So you're trying to hold the connector here. So when you put the wire in, you could rest it, the insulation, the edge of the insulation against that step, and then actually perform your final crimp. So let's see if I can kind of show this on camera. Very difficult to see. Yeah, so I'm going to have to just crimp this and kind of show you when it's done. All right. May have to go smaller. May have to do 26 to, let's see here, 32 to 28. That should have been small enough. All right. Let's see how well it did. Okay. So, let me get these, let's see if I can get a little extra light on there. Oh, there we go. A little bit better focus. There we go. So like I was saying, so insulation pretty much butts up against this. The center is what grabs your conductor. And then this part right here is what actually grabs your insulator. And that's what holds everything together. Now, singularly, plugging on one wire at a time, you're probably going to yoink something loose. So that's why it's kind of like a collective deal. The more you have, the more circuits you have in your connector, the better you are. The less likely you're going to be to pop stuff off. All right. So that was the blue one. Give a good look, Lou. I mean, it's okay if you're not completely butted up against with the insulator, but as long as the insulation is grabbed, that's more than enough. That's all you really need. That's your key to holding power, is to grab hold of the insulation. So I'm going to go and switch back to my webcam. Boop. Tell you what, this phone's been a champ at doing this. No flickering, no nothing. So we're just going to crimp the rest of these little guys. Boom. Yeah. All right. yeah. Yeah, it's definitely a cool process. So let's just check our work. Get you up under there. Okay, like I said, that should wrap around the insulator. Well, if it actually crimped or not. Doesn't look like it did. I'll have to do some electrical tests. Yeah, I don't know. I might have to... Is it on the right die? Sometimes you have to switch over to another small die if it didn't grab. Because that doesn't look like it's completely complete in there, even though that's one of the smallest. Okay. Just recrimping them in another set of dies just because I'm not sure if it actually... There's nothing wrong with double checking your work and making sure you did it right. Yeah, if you've never done anything like this, it's definitely something to get used to. Again, that's why I say buy extra parts, because these little guys, they will go flying across the room. You'll get miscrimps. I can't even begin to tell you how many of these little guys I've wasted over the years just learning how to do this. And even today, it's not like I do it every day, so it's still so easy to mess up. That looks like it actually grabbed a little bit better. So, one of the things we can do if we choose to, now, even though I don't have the right setup with the benchtop power supply, what we can do, I can use my little grabby loos here. Oh, I like that. That's so satisfying. We're going to set the voltage to 5 volts. All right. And we know that, so typically with a fan setup like this, typically if your PWM isn't driven by anything, by default, it's going to, basically, it should be running the motor at full speed. That way, at least it'll run, if I'm not mistaken. Yep. So, yep. So there we go. We got a fan running. Tell you what, this little guy, wow, that thing's really pushing out the air. I mean, it's got more airflow than I expected for its size. I mean, it's blowing that little piece of that little baggie around with the connectors, the plugs in it. So because the way, let me turn this little guy off. Well, that's cool. That's cool. So that tests that. So the way I got it hooked up is it's just grabbing where the actual connector is. So that did validate that our crimps are proper. And we can only assume right now at this stage that we crimped the PWM and the tack leads properly. So I'll clean that up after the video because I don't want to drag on too long. So sometimes, go back to the microscope because I want to show this too. All right, it does. Okay. So let me grab my tweezers again. I put them away without thinking. All right. So I want to show here. It's kind of hard to see, but a lot of times these connectors, a lot of times, not all the time, we'll have an embossed or like pin 1 indicator, but this guy doesn't, unfortunately not. So this is where we're going to just do it the old-fashioned way. So we know with our board, it's going to plug in like this. All right. You can see that, but the interlock connector, well, kind of like the key, is up top. It's going to plug in this way. We know based off of the PCB that pin 1's over here because there's a polarity indicator, little dot. I don't know if you can see it very well. So we know that's pin 1. So according to the schematic, pin 1 is our positive 5 volts. And then these guys, if everything went right, should just slide right in and interlock inside the housing. Yes, they did. So just show you real quick on the microscope. Number 2 is the tack. So that's going to be yellow. So the one right next to the positive is the yellow. Oh, let's turn that on. I want to go turn that on. So 2 is the tack. So we know we have number 1. So basically you'll see that little rise right there. That little, for lack of better terms, like a barb back here. So what that does is you put it in a connector and it interlocks with this plastic flap right there. So you would make sure it's oriented right. And it just kind of like pushes in and interlocks. Wow, this microscope's really coming handy to show you guys what I want to show you. So you can actually see it's pushed up against this. So now, ultimately, you can salvage these. So one is, so this plastic piece, if you could get something up under it, between it and the connector, and kind of like lift it, you can pull the connector back out. You can pull the pin back out and salvage the connector. Just be careful, because it's easy to slip and you can jam yourself. And once you've pulled the old one out, make sure you kind of push the plastic back down, so that way it kind of resets it for the next one. Okay, blue is PWM. So that would be the next logical one. If I can just, there we go. Yeah, wow. Microscope makes everything cool, a little easier. Blue is the next logical one. Again, get a little quiet. And sometimes you can hear like a little satisfying little snap. And you could feel it too when it grabs. So right there. So we've got a wired up JST connector, pin 1, red, which is your positive power, yellow, which is your TAC, pin 2, pin 3 is blue, which is PWM drive, and pin number 4 is your ground. That is so nice to have. Then, so what we'll do is, even though we don't need to, and this would test something, connects right in. And I'm going to tell you right now, this will be kind of cool. Because I don't have anything controlling it or driving it, let's get my voltage set up to 24 volts. Output is off. So without anything on the ESP32 to actually tell it not to drive, it should go on full blast. Yeah, because the PWM is getting a signal. It's basically floating, so it's not getting a signal. So that's kind of a good fail-safe, is you're going to get airflow off of this guy, regardless if you have a program. It's just going to run at full speed. So this has actually been a successful day. We've already proven that the board powers up, that there's no smoke, all the resistances are voltage readings. We've got the fan assembly put together, and that's working. So that's good to go. Let's see here. So we've done a lot of verifications. We've done a lot. So once I cool. And before I get it too far, so right now, according to the power supply, we're only pulling like 65 milliamps. That's not a whole lot. And that's driving the fan at full blast. So again, ESP32, there's no program. We're not doing anything else. But this is a really positive that we've made it this far. No smoke. And everything looks to be A-okay. So what I'm going to do is I'm going to call it here. I thank you for hanging out with me and checking out this video. Really exciting times. We should. I'll get the USB UART chip resolved off camera. I might do that real quick after I end the video, and just make sure I can talk to it. I'll solve that real quick. That way we could get into more testing, maybe firmware writing next stream. So this is good. We're in a good place. So I thank you for hanging out with me, my Twitch viewers. I really appreciate you checking us out and being with us so far, especially with as many videos as we've done. I really look forward to doing more and getting this project further along. Hell, we might even be able to release sooner. Might even be able to have this on the market sooner than anticipated. But again, I'm not going to rush it. We're going to do this right. We're going to get everything documented, tested. And I have to get everything set up for the Magic Forge when I actually go to release this, get more parts in, get everything else taken care of on that side. So thanks. I really appreciate everything. You have a great rest of your evening, and I will see you when we stream next, which should be Wednesday. Take care.